Here is a growing pattern. Number 14. How many dots you see on the first one? How many dots you see on the second one? How many dots you see on the next one?
8.
How many dots you think will be on the next iteration?
16.
What's happening each time? Multiplying by 2 each time. What kind of sequence? It's a geometric sequence. Describe how the number of dots increases from stage 1 to stage 3. How do you get from stage 1 to stage 3? So you really multiply by 2 how many times? So we're going to multiply by 2 times. Which ends up being multiplication by 4, right?
Could you say times 4?
I would not be able to count wrong by that, for that, right? I just want you to see it's repeated multiplication to get there, each step. Write 2 definitions for sequence D so that D of n is the number of dots in stage n. If it asks us to write 2 different definitions, it wants a recursive definition, and it wants an nth term or an explicit definition. So we've got a way to come up with this nth term. Now this time we're starting with n equals 1 though, right? So over here, our nth term, if we start with n equals 1, we'll try to write it bigger this time. Is a of n equals a of 1, first term, times r to the n minus 1. So what is our r in this case? It's 2 right here. R equals 2. So recursively, how are we going to define this? D of n equals. What do y'all think? There's your recursive model right there. R times D of n minus 1, right? Not multiplication, just a function of n minus 1. That's it though. That's the recursive definition. Now for the nth term, starting with n equals 1, this right here is how we do it. So how are we going to find D of n for our nth term definition? Two is the first number, right? And 2 is also the common ratio raised to n minus 1. Is that painless? Is D a geometric sequence, an arithmetic sequence, or neither? And it says explain how you know. Couldn't have said it better myself. Number 15 gonna be easy enough. We'll be able to get it done on this video. An arithmetic sequence starts 84, 77. When you see the term arithmetic, you automatically know we're doing what? Adding or subtracting, right? In this case, we went from 84 to 77. How did we get there? Subtracted 7, right? So our common difference is going to be we'll go ahead and say -7. We're gonna define A recursively. That means A of n is defined in terms of the previous term. How do we represent the previous term? So that's A of n minus 1 is the previous term. And what are we doing to the previous term each time? I think you'd have to stomp on your own toe while he's doing it to make it feel pain. And then we get the fun part to define A for the nth term. So for this one, it didn't tell us if n equals 1 or n equals 0 for the first time. So we get to choose. So we're going to decide. What do y'all want to start with? A of 1 or A of 0? We start with A of 1 equals the first term. That's 84. Then how can we define this arithmetic sequence for the nth term? First term, every time. Yep. Because we started with n equals 1, we do it times n minus 1.
If it was 0, would it be 84 minus 7n?
Yes. And that's how we do 10 through 15. All right, we're at 6 minutes, 37 seconds. I'm going to stop this one.